Hello, everyone. You're listening to Angel Nears, the podcast. Angel Nears is a Silicon Valley community for startup builders where experienced operators share their firsthand knowledge on how to build and scale startups. I'm your host, Oleg Kujikov, and our guest today is Harshil Goel, a co-founder and CEO of Dendrite, a manufacturing software company that aims to unlock the promise of emerging fabrication technologies within production-oriented environments. Harshil has extensive experience in fluid dynamics, orthopedic biomechanics, thermodynamics, finite element analysis, aerodynamics, Lagrangian and Hamiltonian mechanics, and mechanisms design. Today, we're talking with Harshil about unlocking the promise of emerging fabrication technologies within production-oriented environments. But before we get into that, Harshil, welcome to the show.
Thank you for having me.
So that was a long list of what looked like maybe what you studied in college. Is that what you studied in college? Can you tell me a little bit about, from that list of things you are interested in, what the most interesting pieces of it are?
Yeah, so my story is a little bit off the beaten path. So when I dropped out of high school, I went and I found a mentor at Berkeley. His name is Dr. Kahan. He's actually the inventor of floating point arithmetic, and basically he told me to take as many classes and as many subjects as humanly possible to confuse myself.
Why would he? Yeah, why would he say that?
So he said that because he proposed a way of learning called casual confusion. Basically, if you take enough knowledge and do it quickly enough, you start to forget where you learned what. And then you start to take things from different fields and apply them to the field that you're currently trying to solve. And so that's kind of an approach that I've taken with my whole life. So, I mean, if you look at my history, I have degrees in pure math, mechanical engineering. I've also taken all the pre-med classes, chemistry and physics classes. So I've sufficiently tried to confuse myself in what I am.
Well, I think you've done a good job. Can you tell me, let's just start here. We're going a little bit about yourself. I actually encountered some Lagrange principles in college. Can you tell me about Lagrangian and Hamiltonian mechanics? What does that even mean?
So Lagrangian and Hamiltonian mechanics is basically, I'd say, a slightly more modern view of looking at physics compared to like Newtonian physics,
Mhm.
right? They're all consistent with each other in various ways, but it's basically just applying more newer math to
Mhm.
physics, right? And if you just took that to its limits, right, you would find even more newer math that you could apply to physics on the relativity or quantum scale and so on and so forth, right? So it's basically just a much more sophisticated way of talking about, classical physics.
Hmm. That's awesome. Were there any like patterns that you saw kind of between the classes as you were doing? What was it? What kind of confusion?
Casual confusion.
Casual confusion. Were there any patterns you picked up from all those classes that you took that maybe fed into your idea for a company, or how did we go from education to business?
So what I sort of realized, and it's become my mode of operation, is if you question things from first principles from a pure baseline mathematical standpoint, if you even question how and what formulas engineers use or what formulas or things, for example, design systems use, you then finally have the opportunity to potentially make something new or different. And so my MO for making companies or even just living my life is constant questioning and trying to basically use core level mathematics to unlock new potential. Because quite frankly, if you use the same tools, how could you ever expect to get different results?
Mm. And what kind of questioning? I mean, I have a podcast here. I think of myself as somebody who questions things, but I imagine you question things in a different way. So can you talk about that?
Yeah. So, for example, people have fundamental ideas about how airplanes fly, or how fluid goes through a pipe, or how equations and geometry should be represented on a computer, right? And the
Mhm.
questioning I'm asking is, why is it done that way? Is there a historical reason for things being done that way? Is there a reason that it was done that way to solve a specific problem, right?
Mhm.
What was the environment that these solutions were created in, and did that environment constrain the solution or put artificial ideas into the solution, right? When
Mhm.
you start to approach solutions and try to get to the environment and ask those questions, you start to really dig into why and how things exist.
Okay, so let's move on to dendrite. How do you say it?
So it's pronounced dendrite, and I purposely make companies that are impossible to pronounce.
What's the logic there?
It's a conversation starter.
It's a conversation starter, and once you get dendrite, you're never gonna forget it. So tell us about what it is. What's your elevator pitch for dendrite, and what's the mission there?
So the pitch for dendrite is we want to fundamentally change and improve how geometry is created, transformed, and transmitted on a computer. So another way of saying that, tying it to what I just talked about, I questioned why and how geometry came to be represented on a computer and asked myself, has computing changed sufficiently to warrant a revisit?
And where do you see these technologies being applied?
So the way geometry is computed and transformed and transmitted is it's almost like breathing air, right? It's if chances are everything in the room that you're in is manufactured by something, and the thing that manufactured it needed to get data from a computer, right? And so one clear and direct circumstance would be for manufacturing applications. That object may have been simulated in something, so it could have been from an analysis tool, and moreover it was probably designed in a computer as well, right? It may have gone through a couple pencil sketches, but at some point you had to figure out a way to take what's in your brain and put it in a machine. And so basically anything that's ever been designed or manufactured is where this is relevant.
Is that CAD?
CAD stands for computer aided design. Computer aided engineering is what I refer to as analysis, and computer aided manufacturing, or CAM, is what we are currently focused on as a company.
And talk about CAM. What is that?
So computer aided manufacturing, or a more modern term is digital manufacturing, is the idea of using a computer to tell a machine how to go make something, whether it be a CNC device or an additive manufacturing 3D printer. And so it is the software that's used to take geometry and convert it effectively into a set of instructions for a manufacturing device to consume and make something.
Tell us the story behind starting your company.
So I guess I'd sort of made a name for myself at Berkeley as being someone who likes solving math problems for mechanical engineers. And in that, I made a bunch of friends in the aerodynamics world, specifically at Boeing. And basically, one day, a couple folks approached me and asked me to help them solve mathematics problems and write a piece of software. And I actually had no programming experience. I mean, I taught the MATLAB and Python class at Berkeley, but I wouldn't consider that a master programming experience. And the interesting thing is, I ended up solving a problem for them and coming up with a way to do something, and basically over the course of a weekend. And since then, I basically got it in my head that okay, I'm going to go make a geometry engine and make that the next best thing on the planet. And so I then decided to leave my PhD program on indefinite leave of absence, bought myself a bed on Amazon, and got an apartment through Craigslist and an office through Craigslist. Literally arrived all in the same day, and founded the company in Seattle because that's where all the Boeing folks were.
Of course. What year was that?
That was officially in kind of the 2017-ish area, but
Mhm.
I'd been talking and figuring out what's what for the better part of about a year and a half at that point.
I see. I see. So you'd been kind of incubating the seed, if those words go together, for a year and a half, and then in 2017 you moved. Talk about building your team. Who are the people behind Dendrite?
The initial team was trying to basically take as many people from the Boeing Applied Math group as I could humanly take. So, because they just had the specific experience necessary to go do that kind of stuff, right? Hiring PhD mathematicians who know how to do this kind of stuff is not trivial. And so, in that process, I found my head of engineering and chief scientist, Dr. Lauder Larati. I also found Nicholas Lederer, who is my CIO, and basically we've been just growing the company since in Seattle.
So speak to the size of the team. How big are you today at this stage?
So that's actually confidential information. Never tell anyone how big we are.
Okay. Well, can you talk more about the people you brought in, maybe what they do and what you're building? I mean, you've explained what you're building here, but why are these the right people for the team?
I think it's kind of twofold. Number one, I only hire people who are smarter than me. That's like a minimum requirement.
All right, so I can't get a job. Continue.
Well, it depends on what you're smarter than me at. You're clearly good at hosting a podcast and personable, so that's something. But as far as mathematics and engineering goes, right? Like I said, I'm not actually a programmer. I mean, I'm self-taught in terms of C++ and GPU programming, but I ended up hiring a team of mostly engineers to go help raise this vision, right? So hired a lot of folks who are very comfortable with C++ and NVIDIA CUDA. Then, in that process, I met my CMO, Sean, who I think, over some time developed a pretty darn good bond with and realized that we all sort of wanted to build the company in the same way, namely a way that is actually trying to solve problems, like real problems, and trying to do it in a way that is actually almost antithetical to the way most other companies are built today.
And what is that big problem that you're attempting to solve here?
I'd say in the short term, it's a it's a data problem, right? Like if you look at the way manufacturing devices have been scaling for the last few decades, what you'll realize is that all of these devices are actually increasing in size, increasing in resolution, and increasing in the amount of metadata it takes to run the device. And if you know basic geometry, you know that if the volume of something increases, that means that the data is increasing cubically, right? It's exponential. And so what we're trying to solve is fundamentally provide a geometry solution that can handle this data and enable these devices, to reach their peak potential. Basically, we're at a unique point in time where the manufacturing hardware has outpaced the software, and we're trying to make the software catch up.
Can you speak more to that? Timing is so important when you're in startups. So you've mentioned that the technology has sort of it sounds like the hardware has kind of outgrown the software. Is that the gist of it? Can you speak more to the timing and why now's the right time?
So the stars definitely had to align, and I don't think this company could have been made earlier. And I think if it was made later, it just wouldn't have made sense or been possible. And so there are sort of three or four key trends that made this happen. So whenever anything happens in CAD, CAM, CAE land, there are there are a few macroscopic things that are happening. Number one, there's usually a major advance in aerospace, right? So if you track the 1950s, the 1980s, the 1990s, and now, right, you'll see Boeing airplanes being built, the space shuttle being built, and now we're in the age of multiple billionaires owning multiple rocket companies, right? And so whenever this industry has a leap, usually it's due to some kind of trickle down demand from the high end aerospace sector. So that's one thing, right? That's new to this decade. The second is major advances in computing. So the original systems that did manufacturing and design were, the Unix systems, way back in the 1950s and 60s. Then we started to move more to the personal computing DOS, era, and that's when companies like PTC and SolidWorks were kind of coming out. SolidWorks is in, like I believe 1993, right? And now we're in the era of supposedly the cloud. I don't think the cloud is the answer here. I actually think the real answer here from a computing standpoint is the GPU, right? We've had a major shift in computing over the last few years. They've been quite literally doubling and tripling in terms of performance. And so the question is, okay, can these new chips, these new types of computers help in this digital manufacturing ecosystem? The final key shift is also a change in manufacturing, right? Again, if you look at the 1950s and 60s, we had NC machines, then we had CNC machines, computer controlled machines, and now we're in the era of the additive manufacturing and multi-axis CNC machine, right? And so even there, now there's a pent up demand that makes this want to go happen, right? And so you mix, new manufacturing devices with GPUs that were fueled by the AR, VR, machine learning folks, and you mix that with this aerospace, industry push. You kind of have a recipe for why I think our company is needed at this specific point in time.
Sounds like quite a few stars aligning. Can you speak more to the chips, the power of the chips today? Because I think you mentioned it there. You're so right. Like every software company is sort of moving towards the cloud these days. How are you intending to use these chips, and why are you choosing to do things not on the cloud? Because that's what I gathered.
Yeah. And the answer is probably a new fad word that's been developing, which is the edge, right? So if you have a manufacturing device and it takes on the order of a terabyte of data, right? You don't want to compute that data in the cloud and then stream it. It would take you too long. It makes more sense to figure out a way to compress that data, send it over, and then explode the data locally, which is why the compute doesn't have to happen in the cloud. It happens locally, on site near the manufacturing device in the edge. So it's a data locality problem.
Okay, next, let's talk about the value prop by looking under the hood. Describe the essence of your innovation.
I think the key here is recognizing that A, demographics are changing, and B, computing is changing. And you can kind of think of us as modern day PostScript. Are you familiar with dot matrix printers or the laser writer?
Teach me.
Dot matrix printers were the thing, in the 1980s. That's how you printed stuff. And then a person you may know by the name of Steve Jobs went to another very smart person named John Warnock, who also happened to be a mathematician and one of the founders of Adobe. And he asked him to basically help create something called PostScript, a way of basically taking content that was created and converting it into something that a machine could interpret for 2D printing, right? And PostScript was really important because it allowed you to make these like high fidelity fonts. The printing, went up in quality. Basically, the desktop printing revolution happened, right? And all these printers were developed, right? PostScript was also interesting because it made the printers cost more because they needed something called the Motorola, I believe it's the 68K, right? They needed a special chip to run. So the analogy there is here, go replace PostScript with Python, go replace the Adobe Ripper with the Dendrite, computation engine, and replace the Motorola with the NVIDIA chip. And now what you basically have is the recipe for effectively 3D PostScript for the modern manufacturing revolution. And so our key value proposition is accelerating essentially the manufacturing pipeline, unlocking the potential of the machine, which allows people to deliver more value for the machines and in turn sell more machines and materials. And then honestly, also unlocking the ability to automate some of these extremely tedious processes, right? Things that used to take 76 hours, or days now can happen nearly instantaneously or in a couple hours on a laptop, right? And that time savings basically translates to a lot of dollar savings and hence the value we deliver.
Help me understand the product a little better. I think you said you're the engine or the yes. So are you a software or a hardware solution? Do you dabble in the hardware? Is it somewhere in between?
So we are a pure software solution. We create a geometry engine, which has a number of components and APIs. And the idea is that we license it to other folks to either build plugins into so that they can make it compatible with their manufacturing device or use it to build software, for example, HP.
So which elements of your product contribute to the value the most for those customers?
I'd say one key aspect is the computation side. Just being able to compute things much, much faster is really important, and that also leads to better rendering and visualization. And then the second side of it is the way we're architected, we're trying to enable people to develop their own IP, right? So this space is very IP constrained. Everyone's trying to protect their own stuff. And we're trying to provide a way for people to protect their stuff, yet be kind of still a part of a larger ecosystem, right? And because the goal is to elevate the industry and enable it to progress faster and further. I'd say the final bit here is basically on the automation side. We provided a way for basically a Python API to be created. And it's basically, in my opinion, turning manufacturing engineering into a coding exercise as opposed to a GUI exercise.
And give me a sense for who's using this. Talk about your users. Who are your customers? I imagine it's a wide range of folks, but who do you see your customers being?
So our customers fall into basically three categories. The first is kind of the machine vendor. So the very public classic example would be HP. We signed a long-term engagement with them. And there are a number of other 3D printer companies who are on our developer council who are evaluating us and in various stages of signing more engagements with us. The second category of customers is what I'd call an ISV, an independent software vendor. These folks also exist on our developer council, and these folks don't make machines, but they make other software. And so we would be a component in their software, a fundamental component, that is. And then the last category is what I'd call the advanced user. Basically, you're an engineering company who makes high performance cars or medical devices or something kind of bespoke, and you want to use our engine to help you kind of overcome some kind of computational or geometric hurdle, basically.
Let's talk about who else is doing this. How competitive is your market?
It's so our market is basically an oligopoly. There aren't that many people in the world with geometry engines, and there aren't really any who are going around GPU accelerating them the way we're trying to do it, especially so in the manufacturing industry. So, to be honest, I don't really consider myself to have any competitors in the space.
In that case, talk about building the market. How do you plan to build this space for people to occupy and find your product?
It's multifold. You'll notice that the way we do our marketing is very partner marketing centric. So we try to elevate everyone that we're working with in some way, shape, or form, whether it be by giving them free software or working with them, as like a startups, or the larger companies and helping and working with their large customers. The other things we're trying to do are trying to sign contracts and things in such a way so that when people build software on our software, it becomes basically free for all of the education market, right? And so we want to grow and build the community by giving away as much free software as humanly possible to anyone who wants to learn, right? Because to me, that would be the grossest thing ever. If I think access to education and information is a key paramount imperative for us.
Talk about that. Why talk about that strategy and maybe you have a history in education. You clearly studied a lot. Why is that kind of part of your strategy there?
It's a part of the strategy because it's like getting people addicted, right? Like I want people addicted to computation, basically, right? And I know I shot the cloud down earlier, but I think the cloud has been pitched in the wrong way, right? If you want someone to get addicted or acclimated with a new way of thinking about the world or doing things, you have to kind of lead them with the carrot, right? And so the idea would be maybe you start engaging with us by using it on your laptop. And then very quickly you run out of your laptop's resources. So you think, you know what? I wonder what would happen if I put this on my gaming computer. And then you try it there. And then you try it on like an industrial workstation. And then you put it on a server. And then eventually maybe you do it in the cloud and you're doing millions and millions of iterations, right? The idea here is to kind of lead the customer along using the Socratic method so that by the time they get to the end state, they've kind of fully bought into it, right? The other part here is we're approaching things from a fundamentally different way. And so that just requires time, education, and cultivation.
Sounds like an awesome strategy, and I'm all for it. Talk about, it's been a long time since 2017, a few years now, a few, dare I say, event-filled years. So a lot has gone on. What are some of the key milestones for you that you've achieved along your journey, and where do you stand today? Maybe not as the CEO, but as a company.
The milestones that I'm the most proud of to date would be every key person we've hired I consider a milestone because they have been integral to what we needed to do, as a company, whether it be in the marketing, engineering, product, IT side, or sales, right? I consider every hire a key milestone because we're fairly rigorous about that process. I'd say beyond that, signing, our first deals with major aerospace companies was pretty cool, right? And then I'd say the most recent kind of very big milestone was beyond, making a fully fledged developer council with a bunch of public companies was probably this HP deal. I think it's kind of the beginning of something really freaking awesome. And I'm really excited to work with HP on the adventure that we're about to go on.
For sure. Talk about building your team.
say there may be a blue chip now. I've heard the word boomer stock thrown around. But to be honest, there are a number of people who recognize where I think this industry is going. And I think there's a major opportunity here, right? When people think of HP, they think about computers and things, and they don't really think about the other key things that make them kind of the big head honcho. And so it's certainly going to be interesting over the next year or two. There's certainly an opportunity here.
For sure, for sure. And I think maybe go back and listen to our podcast on landing a elephant. I think we were talking about working with enterprise clients. So I'm interested to hear more about how you hire, because you're very secretive. You don't want to tell me how large your organization is, but you say every hire is a key milestone. So talk about what goes into making a hire and maybe what you're looking for in a candidate.
The hires are always interviewed in a cross functional manner, right? Of course, there's an initial phone screen and whatnot, and we look at your CV and your resume and all that. But at least for me, for example, I don't really care what university you graduated from because I've dropped out of every college or high school I've ever gone to. Right, right. I think it really comes down to number one, evaluating. Of course, on the technical side, but we just on face value assume the candidates that we are fielding have technical experience, right? That's usually not the issue. What we really focus in on is how well they work with the existing team, because I genuinely consider our company like a giant family. It's almost like the mafia. And before you go sign that blood oath and join the family, you have to fit, right? And you have to fit in every sense of the word. And that's why we're very deliberate about who we let in and who we, don't. And so there's a rigorous process by which you're interviewed by, of course, a hiring manager, a number of people in the company, cross functionally. We go through a major round of rating and debating and trying to see if they fit or don't fit. And then finally, usually I have some kind of a gut check to see if folks fit. And I know it's very soft. I don't think there's anything very numerical about it. It's just sort of A's hire A's and B's like to hire C's and D's. And we're only trying to hire A's, and we will keep waiting until we can only find the A, if that makes any sense.
Mm-hmm. Let's talk about tracking progress. You get what you measure in life. So, what's the most important North Star metric that helps you track your progress?
I'd say gross revenue per head in the company.
Okay, can you explain that a little bit?
Essentially, how many $1 million of revenue do we make per person inside the company?
Mm-hmm. And why is that the key North Star metric?
Because it's like a proxy for all sorts of things, right? But basically, it's a way of determining how efficiently capital is deployed, allocated, and spent to get another X dollars of revenue. And if I'm able to optimize to some degree just how much money is being made per the number of people in the company, we're basically building an efficient and hopefully very sustainable long-term business.
Mm-hmm. Makes sense to me. I hope it works out. Let's talk about channels. How do you reach your customers? You've sort of mentioned a little bit about your strategy. Can you go deeper in on that? Like, what is your go-to-market strategy here?
So it's very community focused and oriented. Of course, in pre-pandemic world, there were a couple key trade shows that we went to, namely AMUG, Rapid, and Formnext. These are additive manufacturing trade shows where we met a lot of folks on the machine vendor side. But in the post-COVID world, we're basically throwing all kinds of community events. So you may have heard of us through our Investor Day. Basically, last year, a lot of CEOs pinged me asking me for advice and help fundraising. And enough of them pinged me to make me realize that maybe this is a way that I can give back to the community by hosting an event completely for free for all of them to try to help them get their word out there and help them fundraise. Of course, it doubles as a business opportunity for us because everyone knows who we are now and potentially is interested in doing business with us. And then we also throw developer related events and council related events. If you're on our council, we basically meet twice a year as a group to discuss the industry, the trends, and what we need to go do. And essentially through that and word of mouth, it's kind of developing. I'd say we're trying to increase the number of blog posts and white papers we're doing,
Podcast appearances?
of course. But yeah, we're basically taking a community driven approach through education.
Excellent. And let's talk about money. That's the number one issue, right? How do you make money? What's your revenue strategy?
So we license our engine. That's the simple way to put it. We license our engine. There's like yearly developer fees, which include support and all that, and then we ask for some kind of a royalty on top of that, and that's all bespoke and negotiated on a per basis. I like to say, honestly, at the beginning of every single one of the customer meetings I have, doing business with us is like getting married, right? You don't immediately decide on a blah year engagement or contract with us willy nilly, because what we're selling you is a brain. We're selling you a foundation. And so there's a dating process, there's an evaluation process. Then we all sign a prenup, and then we get married and we last for years on end. Right. And so basically, all of our engagements are long term licensing engagements.
And who makes the purchasing decision at these companies when you're speaking about sales? Is it the CEO? Is it a chief technology officer? Who is ultimately in charge of buying?
Usually there's like a VP of software or a CTO who's involved. And because, doing business with us is like getting married, because we're providing core foundational software, right? It's not like an app that you buy for $5 a month. Usually, the CEO is involved in some way, shape, or form because it represents a strategic decision for the company.
Okay, let's move to leveraging learnings, leveraging your past learnings. How do you look at your previous experience both as an aeronautics startup CEO and a robotics researcher today, and what are you bringing from those experiences into your current role?
Yeah, I'd say if you build it, they will never come. It doesn't matter how good of a mousetrap you build, no one cares. And it pains me to say that, right, as someone who deeply cares about technology and whatnot. But what actually matters is how much value you can deliver in a very substantial economic way, right? So it doesn't matter how good of a mousetrap you build. If it can't translate to a business impact, it doesn't mean anything, right? So that's one. The second key thing is basically money is king, right? Trying to figure out a way to stay revenue positive, or make a bunch of money upfront to fuel the growth is king, because constantly necessarily needing to go raise financing, or constantly needing to get loans, or constantly, being at the beck and call turmoil of a financial market that could go up or down depending on a global pandemic. Basically, figure out ways to de-risk the company as soon as humanly possible, and it's always a balance between marketing risk, product risk, and business risk. And so, I consider every day basically of my job as de-risking the company in some way, shape, or form.
Yeah, I want to know who hurt you, Harshil. That sounds like you learned from experience some tough lessons.
I'd say this: I'm a very critical person, and I think everyone who knows me knows I'm critical of them. but, but I'm also incredibly critical of myself, right? And so, do I have nightmares and worries and anxieties about things? Of course. But, I take those things and I fuel that rage, anger, frustration, and anxiety into hopefully something extremely positive.
Yeah, I'm getting pumped up just listening to you. So you're talking about challenges. What are the biggest challenges? Well, let's start with this. What are the biggest challenges you've addressed to this point? And next, I'll ask you about what you still need to address.
I think to this point, we've addressed a number of key technical challenges. There are years more of technical challenges still yet to address because it's a never-ending, marathon. Um, I think by signing some key, very public contracts, we've also addressed the, will they live, won't they live situation, aka I'm going to be here forever now, right? Unless I totally mess up, right? Which is possible, but I have a team of very smart people around me. I think the key challenges yet to address is figuring out how to truly leverage and educate an industry that sometimes just doesn't want to listen, even if it's for their own good, because they're used to doing things in a certain way. And even if it's going to unlock potential for them, they don't want to do it because of fear, anxiety, or just stupidity, quite honestly. So, figuring out a good, positive way of kind of educating and evolving the industry is, I think, going to be a challenge that I'm still learning and tackling and trying to figure out what's the most efficient way to do.
Teaching is very difficult. All right, well, this will be kind of my last question here. You have a background in math. I think that's awesome and interesting. Can you talk about what drew you to math? I'm sure you started at a young age and built on top of it, right? So, what was it about math that kind of attracted you when you were discovering it? And what do you just talk about math? Why do you love it?
So, believe it or not, I actually thought I wanted to be a lawyer initially. And after going into that was I realized I didn't like law. I just liked the philosophy of it. And when then I started taking all the philosophy classes I could possibly take. And then I realized I didn't like philosophy. What I really liked was logic. And if you draw that curve, what you realize is the utter essence of logic ends up being pure mathematics. And so, what I view mathematics, I view it as like my love, like the thing that I'm married to. It's the thing that when you learn and you figure out and you start to try to understand, it basically rewires your entire brain. Like I genuinely believe that I look at things and think of things in a very different way to the people who haven't studied pure math because it's fundamentally changed the way my brain's made up. And so what drew me to it was, there's a euphoria that's associated with solving hard problems. I've always had a love for learning, and it was basically the hardest thing I could possibly find to give my brain a run for its money, right? Like to me, honestly, all of pure mathematics is monumentally harder than every other subject out there. And so it made me think, okay, if I could use this, if I could, for example, engineers, right? Engineers use a set of mathematical tools, right, to go do things, right? But it's the mathematician who's tasked with inventing the tools to begin with, right? And I thought it was a really neat idea to say, you know what? This is a really cool, challenging problem. It challenges my brain. But how cool would it be to become the person who makes the tools that drive the rest of the world? And it just so happened that I ended up taking all the classes in geometry, topology, differential geometry, and then taking all the mechanical engineering classes in fluid dynamics and basically replicated what I presume someone like Gauss, Euler, or Bernoulli did back in the day. And it sort of seemed inevitable that I would end up in this position as someone in charge of a geometry company.
Who are your heroes? Is it the Gausses and the Lagranges of the world? Who do you look to for inspiration?
So I, I'd say I don't think I measure anywhere near someone like Lagrange, Gauss, Descartes, or Euler. I think that would be foolish of me to say because those were truly famous, awesome people. They were in a different class in and of themselves. But what I will say is my heroes and folks are people who question the status quo and question the fundamentals, regardless of what field they're in. And I look to learn from them to see how they get people to kind of change their mind, right, about various things. Because to be honest, if you can get someone to change their mind about something, something major is probably going to happen, whether it be the politics space or the engineering space or what have you. One of my favorite quotes is from George Bernard Shaw. He said, "The reasonable man adapts himself to the world. The unreasonable one persists in trying to adapt the world to himself. Therefore, all progress depends on the unreasonable man."
Speak to that. What does that mean to you?
It means that if you're trying to do something and change the world, you will be dubbed insane, right? Like if you truly want to make a dent in the universe, you will be dubbed insane and you're going to have to push through that in some way, shape, or form. And it's really difficult to tell whether you are insane or not insane. And I think it does take some level of insanity to make that change. And it takes perseverance, determination, and quite honestly, a lot of luck, hoping and waiting for those stars to align.
All right, this has been great. Any final thoughts here before we wrap up?
No, I appreciate the opportunity to talk here on this podcast. I appreciate you're an awesome host. And, if anyone has any questions or thoughts, we're always welcome to ping me. If you're also a company and, as a startup and you're in the manufacturing sector or, geometry sector or things like that, always happy to help you, or you should definitely apply to one of our investor days. Trying to figure out different ways to give back to the community.
Awesome, Harshil. Thank you for the kind words. It was It was great to have you on here and learn from you. I definitely learned a lot. Let's plug those events you mentioned earlier. If I'm listening and I'm interested to hear about maybe the events you're putting on, where do I go?
Our blog or LinkedIn is probably the best to find them. We have an event coming up in February around computing in the manufacturing sector. We have another event planned for April, and we're always trying to find other ways to go do these events. I think we're going to get encored for another Investor Day soon enough. So if you're interested, just stay tuned and follow us on LinkedIn.
Awesome. We're going to end it there. If you liked our show, please subscribe wherever you get your podcasts and leave us a rating, but only if it's a good one. Harshil, thank you for joining today. I really appreciate you sharing your time.
Yep. Thank you for having me. Cheers.